Hello and welcome back for another presentation in your California geography course. This time we're going to be examining California's coastal regions. So we're going to start at the northern point of the state and work our way all the way down to the most southern point, looking at the coastal region broken up into sectors and smaller sections, so we can kind of look at and compare the geography, the geology, the culture, and things along those sorts. Don't forget, we'll be throwing in some plate tectonics. We'll be talking about that Farallon plate once again because it's a pivotal piece of our history and geologic time found within our coastal region. So anyway, that being said, let's get going. All right, so our introduction to the coast. I know there's going to be a lot of words here, and I don't feel like I need to read them all to you, so I'm going to talk about each area on this PowerPoint to kind of push through it. So this is a great opportunity to snip it, take a screenshot if you want more of the finite detail, but I just kind of want to work through it. So as you can see on the right hand side, I've kind of created a map of California, and we've outlined the entire coast based on counties. What counties are coincided with the description of our coast. You'll see later on that there's a couple areas like Ventura and up here in the Bay Area that there's a little bit of ambiguity as to where it really belongs, and that's just because they're great places and everyone wants to claim fame to them. So to begin, we're looking at formation and geologic features. So plate tectonics, Farallon plate subduction. We're going to have uplift. Remember, the San Andreas Fault is the boundary between the Pacific Plate and the North American Plate, and it pretty much coincides with the full length of our coastal range. So we have to acknowledge that part of the state, the coastal part, is technically part of the Pacific Plate, and everything else is part of the North American, except for those small exposed spots of the Farallon that are in between. Anyway, over those millions of years, the plates have converged, causing Earth's crust to fold, subduct, uplift, and that's why we have some of the most unique features that we'll discuss later along our coastline. And like I said already, we have to pay due where it's respected to the San Andreas Fault. Now, because of the tremendous amount of latitude that the coastal range covers, we see there's a lot of ecological significance of our coast. So we've got many inhabitants that are what we consider endemic animals and species, which means they can only be found in those spaces. A very unique biodiversity and hub. As an example, I'll mention that there's also the monarch preserve in Goleta. That's one of the only places in the state that as the monarchs migrate, they stop there in that little spot in that grove of eucalyptus trees, and it's unique to California. We also have the Redwood forest, which are some of the tallest trees in the world. And we have a ton of wildlife habitats along the coastal range, including deer, elk, black bear in the north, mountain lions. We have a very unique biodiverse background and ecological system, wetlands, tons of wetlands and crawfish within the southern coast. So we're very unique. Our latitude is due to that because if you notice, and if you go back to other lectures, the farther south you are, traditionally, the warmer it is because you're closer to the equator. And as we move farther north, we receive less hours of daylight. It's going to be a lot, we're going to see a big difference in seasonality and coolness. And also in that our water, our waves come in at an angle, leave at an angle, and work their way down the coastline. But the water that's coming here has already passed through Alaska, a little bit of Canada, and moved it all the way down. So it's cold water working its way down as the water continues to work its way down as waves within our currents. The longshore current itself, it because of excessive sunlight, it's able to warm up, and so we see very different ecological and biodiversity. Now, some of those human impacts along our coastline, the biggest one's development. People want to live at the beach, but we find that due to coastal erosion and earthquakes, it's not probably the best place to live, but if you've got money, that's where they tend to go. But we see there's a lot of the coastal ranges has a lot of development within housing, agriculture, urbanization, railroads. So we've seen a lot of change in the actual Earth itself along our coastlines that was completed by human interaction. But there's been long-term effects of that, including extreme mass movements and landslides. There's also conservation initiatives to protect the coast, going back to that biodiversity, state and national parks, and also kind of conserving historical cultural points of interest from early indigenous Californians and the peoples that were here. And then moving into challenges, the coastal range continues to face challenges such as climate change, invasive species, and so on and so forth. Now, there is some economic importance to our coastal, not just the range itself, but that realm, especially when it comes down into the southern half. Agriculture is prime here, especially in places like Ventura County, where we produce tremendous amounts of avocados that we can, at any given point of the year, we can provide over 70% of the avocados that are seen across the United States. That also includes citrus, berries, even lettuces, rice. There's a tremendous amount of agriculture that occurs along the coastal boundary between the ocean and California itself. And then going back into natural resources, we found that there's tremendous resources along the coastal realm as well, including oil, natural gas, and then going back into really solid soil that is great for growing. Not solid in structure, because we find that a lot of the soil is compacted sandstone, and that erodes rather rapidly. All right, so let's begin with the North Coast. So that's the northern part of our state. As you can see, it includes the most northern tip down into the Bay Area. So it's known as the Redwood Empire or the Redwood Coast. It's the northern coast along the Pacific Coast. The boundary is San Francisco to the Oregon border. Some of the counties that are involved here are Mendocino, Humboldt, Del Norte, and sometimes includes Marin and Sonoma. That's also part of what we consider our Bay Area, but they're technically part of the northern coast. So how do we categorize these? We look at the soil types, the climate types, and the overall even industry. So let's look at the geology and landforms that are found in the northern coast. And again, we'll wrap up with a little bit more of that San Andreas Fault. So we have what we consider the Franciscan complex. So the bedrock of the northern coast range is primarily composed of Franciscan complex, a diverse mix of sedimentary and metamorphic rocks. This varied geology contributes to the region's rugged coastline with coves, beaches, and headlands. So because you have a mix of this metamorphic and sedimentary, we can see that there are areas that are more susceptible to erosion, which gets to create some great erosional features such as archways and so on and so forth. But then we also have that cap rock and other areas that will be harder or more resilient and will not erode, which holds different features in place. So we can see, and you'll see later, looking at things through the development of perhaps a sea arch into a sea stack, where you have actual archways that collapse and then you create these big columns that are found out in the ocean. Oh, here I'm getting ahead of myself. That's the next bullet point. So sea caves, stacks, and arches. So the relentless force of these waves eroding at these cliffs, removing that material that's softer, can create caves, which caves have one way in, one way out. Tunnels go all the way through. At some point, a tunnel will develop, which will create an archway, and then that archway will collapse, creating a stack. We also have evidence, and we'll see that throughout most of the state, of marine terraces. So these elevated platforms that represent ancient shorelines provide evidence of the coastal's uplift over time. So as the waves are crashing against the beach face may receive an uplift, and then a new beach face will develop. Well, that is stored in time, and we can examine the wave types. We can, the actual angles in which they came in, the grain type itself, and we can do carbon dating with fossil record to find out, how long ago was this down here, and so on and so forth. And then again, we bring in the San Andreas Fault. This is home to what's considered the Triple Junction. The San Andreas Fault ends at Triple Junction, where the American Plate, Pacific Plate, and the Gorda Plate all meet. The subduction of the Gorda Plate beneath the North American Plate is driving up the northern coastal range, and then our plate movement, this ongoing movement of these tectonic plates, continue to shape the landscape of the Mendocino coast, contributing to its very rugged terrain and active seismic activity. So here we have an image of that. Here we look at the San Andreas Fault, Pacific Plate, the North American Plate, and we can see this. You can actually see the red line represents the San Andreas Fault. So this part here is what's over in here. Go back over here. So as we can see this continued change, we can see that there's motion and there's tearing apart of the earth, kind of in a sense. It's sliding past, back and forth. So going back to the North Coast, we can look at the physical geology. What are some of the big factors when it comes to environmental hazards? Tsunami risk, so due to its proximity to the Pacific Ocean basin, the Mendocino coast is susceptible to tsunamis generated by earthquakes as far away as Japan or even South America. We have excessive coastal erosion, so we have cliff retreat occurring because as the waves come in and crash in, we have an erosional landscape that is pulling material away. And then we have that uplift that creates those marine terraces and diverse ecological background. So each marine terrace represents a distinct period in geologic time and supports a unique vegetation community. This creates a fascinating ecological staircase showcasing a variety of ecosystems within a very small area. All right, so that's kind of an intro to the northern coast. So now we're going to move into the Bay Area. All right, so the San Francisco Bay. So the geographic location surrounds San Francisco, San Pablo. The Suisun Bay estuaries includes 9 counties going from Alameda all the way to San Francisco. The core cities, of course, within this region are going to be San Francisco, San Jose, and Oakland. We can actually look at the demographics of this area. The population is about a little over 7.5 million people, and extremely ethnically diverse: Hispanic, Asian, African American, and Pacific Islander. It's also home to a lot of our tech companies. And in further studies, and we'll continue to see this in the future, the COVID-19 impacted this area extensively. Without having to go into too much detail, we find that this part of the state has a very, 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 very high cost of living, and it's because of the amount of tech and other economies that are found in this area. So naturally, it's going to be more expensive. So anyway, due to COVID-19. During that pandemic, people were given the opportunity to work remotely in most cases, and many people left. So they fled. There was a huge decline in the population. But now that people are going back to work, they're seeing an influx, and then they're also seeing properties values increasing because of a displacement. So it'll be a whole new thing to study, just that alone. The pandemic, how the pandemic affected really the urban and human geography of that space. So the environment, ecologically important as well. You have more redwoods, earthquake prone, and very temperate, mild in its climate. So yes, it rains. It can get a lot of precipitation, but it's rather mild. It's not very, very cold. Okay, so here's kind of a background on the physical geology of the San Francisco Bay. So it is along that San Andreas Fault, so about 20 to 30 million years ago, there was a subduction of the Farallon Plate beneath the North American Plate, creating a volcanic arc that would eventually become the Sierra Nevada, which we'll cover in a different presentation. As that Farallon Plate continued to subduct, it fragmented, leaving behind smaller pieces of oceanic crust. It would later become part of the Bay Area. Now, running through this is our San Andreas Fault, which was the result of that plate tectonic activity. Now, some of the rocks that are found here, we've got, as mentioned, metamorphic, volcanic, and sedimentary. So we have metamorphic, igneous, and sedimentary rocks all within this area. Metamorphic rocks appear to be the oldest in the Bay Area, as they're found in part of what they call the Silurian block. These rocks were originally sedimentary sandstones and limestones that were buried very, very deep and subjected to high temperature and pressure, creating a new type of rock, metamorphic, such as schists, gneiss, and quartzites. Now, the next type of rock, volcanics, this has again to do with that subduction of the Farallon Plate left behind deposits of volcanic rocks such as basalt and andesite in various parts of the state. These rocks can be found in places such as East Bay Hills, the Santa Cruz Mountains, and other areas. Now, the final one is sedimentary. In addition to these other types of rocks, the Bay Area and this whole region is also made up of sedimentary rock, including sandstone, shale, and limestone. These rocks were formed from the accumulation of sediments in ancient oceans, lakes, and rivers. We find that this is because there's a delta environment when it comes to a lot of our rivers that dump all of that's material, all the water, and the grains that are within that water out into that bay area. All right, looking at the physical geology, so there's ridge structures, fault zones, blind thrust, and then we have some historic earthquakes. So the ridge structures, there's 3 major ridge structures in the Bay Area. You've got the Santa Cruz Mountains, the Marin Hills, and the Berkeley Hills. They're all roughly parallel to the major faults and represent the result of compressional forces between the Pacific and the North American plates. Faults, there's plenty. As you can see, there's things, the Hayward, the Concord, the Calaveras, there's lots of different faults. Many of these are still very active and prone to earthquakes. So it's not just the San Andreas, there's also these offshoots and other faults that represent within this area. There's a thing called a blind thrust fault. These are hidden faults that are particularly dangerous because they can rupture without producing superficial breaks. They are associated with portions of the Santa Cruz Mountains and the northern Diablo Range, which is where the Diablo winds used to come from. Like we have the Santa Anas, there was the Diablo Range for the Diablo winds. So these blind thrust faults exist, and normally what we'll find on our surface is fault scarps. We can see the remnants of faulting, but sometimes we can't, and so unless you have a data set behind it, it's not known where it is. And then there was obviously some historic earthquakes in this area, the 1906 San Francisco earthquake and the one in 1989. Those are 2 of the largest earthquakes that occurred in the Bay Area. The 1906 is one that you can dive into for days. Most of the area, not only was there an earthquake, there was a massive fire that burnt down most of the town. So they just bulldozed everything in the ocean and built on top of it, which is it's not sustainable. It's crumbled. It's not compacted earth. It's the leftovers. But nonetheless, let's look at this. So here we have a zoom-in photo. This is a slide subtitle. I guess I can get rid of that because there's no subtitle to have. Well, I guess it won't go away. The photo on the left is using Google Earth, so we can see the San Francisco Bay. We can also see all of this material that's being moved in, this high suspended load from the surrounding rivers. But then we move over to the right, and here's kind of, shows a little bit more, but this is our generalized geologic map of the Bay Area. So Quaternary sediments are the most recent that we have. Most of those were brought in from, the remnants of glacial melt. But we can see different types of geologic time, the different types of material, sedimentary, volcanics. Actually, what's neat here is you can see there's serpentinite, which is the state rock that's found in this area, and there's quite a bit of granite that exists as well. So nice geologic map to go with it. Here's the Hayward. The Hayward Fault runs right through here. There's your Calaveras Fault, and then the San Andreas Fault is parallel to all of these. So a very active place. In fact, you can see the Hayward Fault that runs right here. We can see it right here as well. So that's why I like these images, because then you can see where these faults go, where the Calaveras, where the San Andreas or the San Gregorio, where they align. All right, so that is the Bay Area. Next is the Central Coast. All right, welcome to the Central Coast. You'll notice again some discoloration. Here we have Ventura County. Is it part of the Central Coast? Is it part of the Southern Coast? Depends on who you ask and how you look at it. So we try to address that in the book, but there's very big differences and very big similarities. So that's why it kind of gets thrown into both. But anyway, the coastal this part, the Central Coast, goes from Point Mugu all the way to Monterey Bay. Part of the Central Coast, so the Central Coast American viticulture area. This is like a hub for agriculture. Northwest of Los Angeles, includes parts of the rugged Big Sur coastline. So some of the counties that are associated are Ventura, Santa Barbara, San Luis Obispo, Monterey, San Benito, and Santa Cruz. So these are all areas that are within here. These are all areas that are prime in agriculture as well. So let's look at the physical geology of the Central Coast. So the coastal plain and geologic formations, we have a very, very, very complex depositional history. The coastal plain is a patchwork of Holocene and Pleistocene deposits, which include river deposits, slope wash, marine deposits, and terraces. The predominant soil type is the Milpitas cereus, which is a well-drained brown, fine sandy loam. So because it's a fine sandy loam, it's going to have some clays and silt as well, not as much, mostly sand, but it is great for drainage, and which you do find in most cases is very good for certain types of agriculture. Now, this area is also experienced rapid uplift. The entire region, including Santa Barbara, has experienced significant geologic uplift. This is evident in the coastline bluffs, and it's also evident with where the marine terraces are. They're very, very high elevated, and that is the result of dramatic and very quick episodic uplift. Now, when it comes to faults and seismic activities, there's the Mission Ridge Fault Zone. This fault runs along the Riviera Hills and converges with the Mesa Fault near 5 Points. And there's also the Mesa Fault, which defines the northern boundary of Mesa Hills and is believed to cause the very devastating 1925 Santa Barbara earthquake. So, what type of rock do we find? So, there is a sedimentary bedrock. So, you've got the Monterey, the Siskaka, and the Santa Barbara formations. These formations are composed, the first one, the Monterey, is diatomaceous earth, which is a type of sedimentary rock made out of the accumulation of diatoms or skeletal fragments. Then the next formation consists of sandstones, shales, and conglomerates, which means it's a mixture of rounded, usually grain size larger than an eraser head on the end of a pencil. And then you have the Santa Barbara Formation, which is a significant aquifer unit containing coarse-grained freshwater-bearing sediments. So the Santa Barbara Formation allows water, because of how coarse-grained and that there is porosity, that water is able to infiltrate and travel along through it as an aquifer. There's actually the Moore Ranch Fault prevents what we consider seawater intrusion. So when you have something that is very porous, water is able to transfer, obviously in one way, but depending on the density and pressure, it can run the other way. So that kind of prevents it from intruding and then destroying or contaminating the groundwater. Then you have the Santa Ynez Mountains. They're composed of multiple layers of that sandstone dating all the way back to the Jurassic Age. We've had uplift and change, and as a result of all of this type of material that is, for the most part, very soft and readily exposed and eroded, this area is very susceptible to landslides and debris flows. So these steep slopes and active geology makes them prone to landslides and debris flows, which pose hazards on the surrounding areas. So, you hear often about Montecito as a community that, the roads and residences are damaged by landslides. This area is very prominent to that. Now, culturally, obviously there's culture everywhere throughout the state, but there's a lot of recorded culture here. They have what we consider pictographs. So you have petroglyphs and pictographs. Petroglyphs are carved into rock, but pictographs are painted. And so there's a lot of, we go back to pre-colonial periods, you have the Chumash people that have been here for over 10,000 years. There's evidence of this going back, to the Pleistocene epoch, which is when there was a time in California when we had mammoths and very large camels and all kinds of fun things. That was during the end of our last ice age. So most of the people that were here were hunter-gatherers and fishermen and traders, and they would swap goods, beads, furs with your local tribes, Mojave, the Yokuts, and the Tongva. The Tongva is closer to Santa Clarita. The Mojave is more inland. Cultural heritage, known for their intricate rock paintings, highly skilled basketry, and the use of these plank canoes made out of balsa. They were able to, because at that point, most of the Central Valley was wetlands or marsh zones, so they were able to create these very lightweight boats and travel up and down the state of California. So trade routes, Chumash canoes were launched from mainland points like Ventura River, Magoo Lagoon, and Point Wainimi to trade with the Channel Islands. This led to speculation about potential prehistoric contact with even Polynesian peoples. And then there were some linguistic connections. So linguistics suggests possible connections between certain Chumash words and Polynesian languages. So, this is an ongoing study, but it'd be really fun to think that there was that type of connection that far back between two different groups of people. So an icon here, case study, we're looking at the culture of Ventura. We have Mission San Buenaventura. So European arrival happened in 1542 when they first got to this area. Cabrillo was there. They founded the missions in 1782. In the area, there were land grants that were very prominent in the region. The Spanish government began granting land concessions known as the ranchos to Spanish Californians, including the Rancho Simi and Rancho El Conejo in Ventura County itself. And obviously Spanish influence is huge in the area, not just with the mission-style architecture, but religious practices, and then it left a long-term shift onto the landscape, especially when it comes to the design of our street signs and the languages and street names and ranches along those lines. Moving forward, looking later during the land grant area, so Mexican independence occurred in 1822. California became part of Mexico, leading to changes in governance and land ownership. The missions began to decline. Secularization occurred. The Mexican government secularized the missions in 1834, transferring their land and resources to secular administrators, and then the land grant part began breaking apart. These bigger conglomerates. Mexican Californians continued to receive land grants, further shaping the region's agriculture and economic landscape. So this is a very, very old map of actually the city of Ventura in Ventura County. So you can see that this is the ex-mission San Buenaventura. This Nordhoff, which is a term that you see that a lot in the agriculture, especially the old fruit boxes, the Nordhoff group, and they were based also out of Northridge, because it all kind of it would interconnect at some point when it came to traveling. So other things that are prominent in this area as well: oil. So going from a territory to a county, so the Mexican-American War began in 1846, resulted in California becoming a U.S. territory in 48. The Ventura County formation happened in 1873. Ventura County was officially separated from Santa Barbara. So we saw this separation of the two. The railroads arrived. The Southern Pacific Railroad arrived in 1887, boosting economic development and transportation, especially when it came into the sugar beets and the berries and walnuts and citrus. And then in about 1916, the discovery of oil caused a huge economic boom in this area. In fact, there's a beautiful oil museum in the town of Santa Paula that talks about the importance of what oil did for this region of the state. Although not the first oil town, but it was the first in this area. All right, so then we go down here. Let's look at Ventura as a case study. If east versus west and how it's divvied up. So that's broken up by the Conejo grade, separates Ventura County into East County and West County. East County is known for its hills and valleys, suburban communities such as Newberry Park, Thousand Oaks, and Simi Valley. The west side is known for places such as Oxnard, Ventura, and Ojai, which is much more agricultural, and also includes parts of Channel Islands. Population growth: the county has experienced significant growth in the 20th century, particularly on the east side, due to its proximity of Los Angeles. Now we're seeing the west side being more developed of this area. We're seeing substantial master plan communities within places such as Fillmore, Piru, and Santa Paula, and parts of, it's Sataquai. In the town of Sataquai, we're seeing more development because these are people want to have homes that are an easy commute to Los Angeles, but also you have some land, and these homes do have that. All right, so bringing us here, here's some photos. Again, a photo of the Central Coast, one of the most iconic bridges in the area. Look at this coastline that has been uplifted. Not so solid. A bit farther up here, you can probably see some additional of those terraces, but you can see that we're having an active beach development down here, and there's obviously erosion. So looking at our image right down here, we can see that we're talking about places that are right around here. So things pretty much north of that Garlock Fault. We can see there's some additional faulting there as well, but nothing too out of the ordinary, but very, very diverse. So what happens for us is if I go back a slide, so we can see that Ventura has been highlighted here, and we come down here to the south coast, we see that Ventura is they're still hanging on, and I think that has a lot to do with not just its culture and its proximity, but I think the Channel Islands cause a bit of that because they kind of get sucked up into the southern part of the state because it transcends. The Channel Islands are essentially offshoots of the Santa Monica Mountains down in here, so they're interconnected in LA County. But anyway, next part, the South Coast. All right, we did it. Now we're at the southernmost part of our state, the South Coast. The South Coast encompasses the southern third of California's coastline, primarily consisting of Ventura-ish, but Los Angeles, Orange, and San Diego counties. Defining characteristics, SoCal culture. SoCal, dude, right? That's this area. Major urban coastal centers, exclusion of certain areas of San Diego and Ventura. We'll talk about that. The geology is very unique. Channel Islands exist. They are a westward extension of the Santa Monica Mountains, the formation through uplift and then submergence by the Reyes Fault, volcanic intrusions such as Sandstone Peak, and of course the Malibu Creek erosion. Malibu Creek is a state park that exists that you can visit. That's part of where MASH, the old TV show MASH, was filmed. Some sources within the region variation include parts of Riverside, San Bernardino, and Baja, just due to its bioregional similarities. So there's a little bit of overlap, as you can see, within these counties. So the geologic setting. So we have the Pacific Coast Ranges. The south coast of California is part of the Pacific Coast Range, a vast mountain range system that extends all along the Pacific Coast from Alaska to Mexico. You have the Santa Ana Mountains, the largest natural landscape in Southern California, known for their rugged peaks and scenic beauty. You have parts of the Santa Monicas, the San Jacinto Mountains, the Santa Rosa Mountains, and Laguna to the south in San Diego. So we have all these different ranges that exist, and most of them end up converging or parallel to one another. So we've got this really unique geologic story. We also find in the southern part where we see a lot more geothermal activity as well. All right, so faults and seismic activity. So the formation of the South Coast is primarily due, again, to tectonics, specifically the interaction between the North American and the Pacific Plate. Over millions of years, these plates collided and created uplift, and voila, having our coastlines and having these inclines that exist along our beach face. The San Andreas Fault plays a significant role. The Newport-Inglewood Fault. This fault runs parallel to the coast and is also capable of producing very large earthquakes. And there's also the Whittier Fault that runs out this way, that runs throughout the Los Angeles basin. Now, the length of the Peninsula Range, which is also running within here and connecting to the southern part, it extends over 900 miles. It goes to the southern part of California all the way into Baja Peninsula. So it's a really large range. It runs out of our state down into Mexico. Now these mountains are part of the North American coastal range, formed through complex interplay of tectonic forces, uplift, and erosion. So here is a geologic map of that area. So here we have the Salton Sea. Well, I mentioned a moment ago that there's a lot of geothermal activity. We're seeing that this area they have got these mud volcanoes, which is a video I did, which is absolutely ridiculous if you're looking for something to laugh at. But we have the mud volcanoes. We're going to have lots of earthquakes, and we're just having geothermal activity because the crust is so thin. And when that groundwater hits a certain depth, it's able to boil and come back up as steam, either as a fumarole or we don't have geysers really in this area. It's mostly mud, but we do have that fumarole or that gas. So we see that there's a unique geology, not just more newer, but we can go back into time in the Precambrian era, but that's more of your resilient, harder rock that's kind of been able to withstand. But again, we can see that these rocks, they are, I guess, technically made of rock, but this would have all been connected to the mainland. But when we had a lot more snow during our last glacial maxima, that snow obviously came from water. At one point, that water came from the oceans that was evaporated. So by removing all that oceanic water, moving it into ice onto the North American continent and beyond, naturally sea level would decrease, right? And in doing so, would create land bridges. And this is all part of the Santa Monica Mountains, and they would have connected. So that's why it's right across from Ventura, but it's technically part of the Santa Monica. So that's why Ventura kind of gets stuck between these two areas. Is it central? Is it kind of central, kind of southern? Like, where is it? But anyway, they were interconnected. And then if you are looking for something fun to research, maybe at some point in your academic background, you read Island of the Blue Dolphins. Island of the Blue Dolphins is a pseudo true story that took place on Channel Islands. It's something to check out if you haven't, if you didn't know that. Maybe that sparked some little memory back in your medulla oblongata or whatever it is, right? Anyway, South Coast. So we broke this up into thirds, technically fourths, because we kind of break it into smaller pieces. But California's coastal region. Boom. So that's kind of an overview of the entire thing. California's coast, north to south. Be sure to check out any of the additional content within the textbook that's been provided in the class. If you have any questions, don't forget, you can just go ahead and comment below and ask away. Don't forget to like, because it makes me feel good. And that being said, you have a wonderful day, and we'll talk soon.